Find the area of different types of triangles. Let's first examine the difference between the three triangles shown on this slide. Well, here we have a triangle that has a right angle, so it's considered to be a right triangle. This triangle over here has no right angle, and all of the angles appear to be less than 90 degrees, or all acute angles. So this would be considered an acute triangle. And then this last one has an obtuse angle in it. So this is considered to be an obtuse triangle. How is the type of triangle related to its base and height? Well, the height of a right triangle is easy to find. It's a side. We usually label a side that looks like the bottom or top as the base, and the side that's on the left or right as the height. However, it doesn't always need to be a side of a triangle. The height of a triangle is also called the altitude, which is a line segment from a vertex of the triangle that's drawn to the side opposite it, and it's always perpendicular. So in an acute triangle, the altitude or height is inside of the triangle, and in an obtuse triangle, the altitude or height can be outside. Is the formula for the area of a right triangle true for all triangles? Let's try to find out. Two triangles were drawn to create a rectangle using the base of the triangle as one of the rectangle's sides. We know that the area of a rectangle is found by multiplying the base and height together. Rotate the triangles so that they cover the yellow triangle. Let's actually see what happens by doing that rotation. If we come out and we rotate this, oh wait, that matches up with the base here. It represents half of the base, and then if I rotate this one around, oh, well, there's the other half of the base. So by rotating both of these triangles, I get the entire base, and then the sides that were originally out here both come together and meet to form the height. After rotating the two triangles, we can see that they cover half of the original rectangular area. Therefore, the area of any triangle is half the area of a rectangle, or area equals 1/2 base times height. Let's see if the formula for the area of a right triangle is also true for an obtuse triangle. So a rectangle is drawn so that its base matches up with the base of this obtuse triangle. And similarly, the height aligns with the height that would be drawn out here of this obtuse triangle. So let's actually take this section that's outside and move it inside of the rectangle. What do you think the relationship is here? What fraction of the rectangle is covered by the yellow portion of the triangle? Are the blue triangles equal to the yellow triangles? We can try and rotate and move the blue ones to see if they cover the yellow triangles. Let's see what happens. If I take the top one, it looks to be 180-degree rotation, followed by translation to get it down. Yep, that lines up. And if we take this one and realign it and move it up just a smidge, yes, look, these teal triangles, or the blue ones, if you rotate them and move them slightly, they do directly overlap with the yellow triangles that were in here. As you can see, the blue triangles are the same as the yellow triangles, and they each cover half of the original rectangular area. Therefore, the area of a triangle is half the area of a rectangle, or 1/2 base times height. Find the area of the figure. Well, we know that the area of a triangle is 1/2 base times height. Well, the base in this diagram is 11, and the height is this 8. So let's substitute these values into the formula to calculate the area. So that's going to be 1/2, the base is 11, and the height is 8. And remember, in multiplication, the order doesn't matter. So we could do 1/2 times 8 and get 4, and then 4 times 11 is 44. So the area of this triangle is 44 square centimeters. Now let's try to calculate the area of these triangles. In the first one, we have a base of length 11 and a height of 10. So 1/2, 11 times 10. Half of 10 is 5. 5 times 11 is 55 square feet for the first one. Now let's look at the second one. Here the base is 16, and our height is not 16 also. The height is perpendicular to it, so because this is an obtuse triangle, it's outside. So this is our height. So let's substitute these into our area formula. 1/2, base is 16, height is 14. Half of 16 is 8, and 8 times 14 is 112, and this is square units. Now let's try to use what we know to figure out how to calculate the area of this triangle. Let's start by calculating the area of the rectangle. We can use the grid to count how long the length and width are, or base and height. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So we have a length of 14, or a base length of 14, and a width or height of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So if we multiply 14 and 13 together, we get an area of 182 square units. Now let's look at the red rectangle. Well, we know the height of the rectangle is 13, and its base length is 1, 2, 3, 4, 5, 6. So we can do 1/2, 6 times 13. Half of 6 is 3, and 3 times 13 is 39. Now let's look at the yellow one. Its base is of length 1, 2, 3, 4, 5, 6, 7, 8, and its height is 1, 2, 3, 4, 5, 6, 7, 8, 9. So 1/2, 8 times 9. Half of 8 is 4, and 4 times 9 is 36. So those are the areas that we can find so far. Now let's continue and find the area of our purple triangle. Its base is of length 14, which is the length of the rectangle, and its height is 1, 2, 3, 4. So 1/2 of 14 times 4, and half of 14 is 7. 7 times 4 is 28. So the purple triangle has an area of 28 square units. If we add up the areas of all three triangles, the red, the yellow, and the purple, we end up getting 36 plus 39 plus 28, which adds up to 103. And then what we can do is we can calculate the difference between the area of the rectangle and the area of these triangles. So we would do 182 minus 103, and when we find the difference, it's 79. So therefore, the area of the blue triangle is 79 square units. This method can be used to find the area of any shape as long as you can find the base and height of the triangles that form the surrounding rectangle. Let's actually try it out. So first what I'm going to do is I'm going to draw the surrounding rectangle. I'm going to make it a different color so that we can see how the different lengths correspond. So we're drawing this out, and as I'm drawing the length and width of the rectangle that surrounds it, the smaller triangles outside are being formed. So we have 4 triangles that we're going to find the areas of. So here's triangle 1, 2, 3, and 4. So let's start by finding the area of triangle of the square or rectangle first. Not sure if it's a square quite yet. So let's count the base. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay. So the area of the rectangle has a length or base of 18, and its height or width is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay, so if we multiply 18 times 18, we get 324 square units for the area of the rectangle. Now let's try to find the area of triangle 1. So the area of triangle 1, it's going to be 1/2. Its base is of length 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And its height is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that's 1/2 of 121, which is 60.5. So that's the area of triangle 1, and it's 60.5 or 60.5 square units. All right, now let's try triangle 2. So the area of triangle 2 is again going to be 1/2. Its base is of length 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And its height is of length 1, 2, 3, 4, 5, 6, 7. So that's half of 77, which is 38.5 square units. So that's the area of triangle 2. Okay, now let's find the area of triangle 3. Area of triangle 3 is going to be 1/2. Its base is of length 1, 2, 3, 4, 5, 6, 7. And its height is 1, 2, 3, 4. And we can do half of 4. That's 2. 2 times 7 is 14. So that's 14 square units for the area of triangle 3. And now let's do the area of triangle 4. Okay, triangle 4 has a base of length 1, 2, 3, 4, 5, 6, 7. So that's 1/2, 7. And then its height is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And half of 14 is 7, and 7 times 7 is 49 square units. That's the area of triangle number 4. And then if we add up all of the areas of our triangles, we will have 60.5, 38.5, 14, and 49. And if we add those up, we get 5 and 5 is 10, so we put the 0 down, and we regroup by bringing the 1 that represents a set of 10ths over into the ones column. And then we have 1 plus 8 is 9, 9 and 4 is 13, 13 and 9 more is 22. So we're going to write that as 2 plus 20, and the 20 is represented in the next column. So then 2 plus 6 is 8, 8 and 3 is 11, 11 and 1 is 12, and 12 and 4 is 16. So that amounts to 162 square units for the area of all of the triangles. So then if we take the area of all of the triangles and subtract it from the area of the rectangle, the area of the remaining quadrilateral that we have is 324 minus 162, and that's going to give us 2 in the ones column. We have to regroup and make this 200 and this 12 tens. So 12 minus 6 is 6, and 2 minus 1 is 1. So the area of the quadrilateral is 162 square units. That's generally what's showing here.